Hey guys, in this video we are going to be going over fossils. Fossils are bones, and we're going to be going over what is the significance of where we find them. So what we're looking at here in this diagram is basically if I look at an area and I sort of like go underneath the grass, what would I see? You can see this if you've ever been to the Grand Canyon. You'll kind of see layers of rocks, or if you've ever talked about sedimentary rocks. Sometimes, especially up north, like if you're driving down a highway and you end up like kind of in the middle of a mountain that they've blasted through, you'll see like layers of rock. But anyway, that's what we're looking at here. The thing that we're taking away is basically how do you figure out which is the newest one and which is the oldest. Well, the furthest you go down in those layers of rocks, the oldest it is. The further, like, closest to the grass is the newest. I kind of like to think of it like maybe your locker. So, probably, if you're like me when I was in high school, you shove a bunch of things in your locker. The thing at the very bottom is, like, your syllabus from the first day of school that you just, like, shoved in there. And then you like stack things throughout the year, and then maybe what's on top, like the most recent thing, is maybe you keep your packet for your biology star review on the top. That's the most recent thing. So that's kind of how fossils work in terms of at the bottom where the oldest, that would be this darker layer, and then this middle layer would have come next, and then this layer would have come most recently. So that means that fossils A and C are the newest and fossil B is the oldest. If you're ever interested in like digging up fossils or bones, that's what a paleontologist does. So it could be a career to look into if that's what interests you. Alright, we're going to look down here. Alright, so what we can see from these bones that we dig up sometimes is part of the reason that we figured out evolution, or like part of it, we haven't totally figured out evolution, but in terms of giving evidence that we think that evolution happened. You may have remembered at some point I had asked you to color the parts of each of these bones. If you would like to create your own key for each of these structures and go ahead and color it, that's up to you. I'm just going to go over a couple of structures. The first would be your phalanges. Phalanges are like fingers. You'll notice if you look down here, you have structures from a bunch of different organisms. So human, whale, crocodile, cat, bird, bat. But they all have these phalanges or finger structures, which is kind of crazy. Similarly, they all have a humerus. So that's this part here. It looks a little bit different on every single organism, but it's still there. If you ever hit your funny bone and it tingles and you're like, oh, you hit your funny bone, you actually hit your humerus. It's a knee slap right now. Okay. What we have here, because they all have these similar structures, they're called homologous structures. Homologous structures are similar in their structure, but they have a different function, aka a whale uses it to swim, bat uses it to fly. Alright, this is one of the evidences for that evolution has occurred, because it tells us that we've evolved from a common ancestor. That's not telling us that like humans evolved from whales. That's not what that means. It tells us that our humans and whales once came from a common organism. Anyway, that was your review on fossils, and then get ready on your practice. Have fun.